Okay, so now we're talking about solving equations with rational expressions. We have to take into consideration everything that we've learned, all right? So in the past sections. So when we start a problem, 4y plus 1 over y equals 2. All right. Yes, we can automatically say, hey, simplify the left side, and we can get common denominators and add and this and that. And that's true. That's not the way I'm going to teach you today. I'm going to teach you one way, and hopefully the simplest way. But you do have to understand also in the fact that what I'm solving for, y, is in the denominator, which means there are answers that will not work. Okay, and you must check them at the end. So at the end, we will check those kinds of guys. So let's go ahead, and what I'm going to do is say, I don't like denominators. So I'm going to get rid of my y. So I'm going to take both sides here times y. And what you'll see that does is when you distribute here, you get 4y over y, which is just 4, plus 1 when you distribute here equals 2y. Well, these guys are the same exact equation. It's just now it's horizontal. It's not got any verticality to it. So now I've got 5 equals 2y divided by 2 divided by 2, and 5 halves equals y. If I plug that back into this guy, it should be correct. Left side equals right side. Now, also, if you don't have time, let's say you get your test and you're going through, you just don't have time to check it and plug it back in, at least plug it back into the denominator. Because if the denominator equals 0, you have an undefined equation or undefined fraction, and you cannot solve that, so there'd be a do not solve. In this case, y would have to equal 0 for the denominator to be 0, and it does not. So at least I know that 5 halves stands a chance. Whether I know it's perfectly right or not, I don't know, but at least it stands a chance of being right. So let's go through the next guy. Let's go a plus 7 over 8 minus a minus 2 over 3 equals 4/3. All right, so I don't want a denominator. Same kind of thing as what I just did. I'm going to take both sides times the common denominator of every single one. So 8 and 3 is 24. So when I distribute here, reduces, I get left with a 3. When I go over here, it comes back out and it goes to 8. These guys reduce. When I distribute, it leaves me with 8. So on the right side, I get 32. On the left side, I get this 3a plus 21. Now be very careful here, because when I distributed this, I got that 8, but it's not 8. It's actually negative 8. The negative has to distribute, so we have to watch out for that subtraction. So it's minus 8a plus 16. Now I can combine like terms. Here again, same equation as what's before, it's just not vertical. So I have a negative 5a, I have plus 37 equals 32. Subtract 37 to both sides, I get 5a negative equals what? A negative 5, and a equals 1. And in this case, I don't have a variable that falls in the denominator, so everything could possibly work. If I want to know if it's right, plug it back up in. Left side equals right side. You know that a equals 1, or 1 is my answer. Well, let's do a problem here where we just got one fraction equal to another fraction. And if I see this, anytime I see one fraction equal to another fraction, cross products works. Well, that's no different than multiplying both sides times x. It would reduce over here, just show up over there, and times that 14x plus 3. So anyhow, cross products, and we go 5x squared equals 14x plus 3. Here again, I've got x squared on this side, so everything else goes over there. I get 5x squared minus 14x minus 3 equal to 0, so I have to factor that and find my answers. I should get two answers. So 2 factors of negative 15 that add to get negative 14 are going to be 1 and 15, right? Going to have to be a negative on that side. I expand my middle term. So plus x minus 15x, and then minus 3. Because my first two and my last two terms, I factor out an x. I get 5x plus 1. I'm going to factor out a negative 3. So I get 5x plus 1. And I get 5x plus 1. I get x minus 3 equals 0. Set my factors equal to 0 and solve. And x equals a negative 1/5. And also a positive 3. If I plug those guys back in at least to the denominator, neither denominator is 0, so I know that that at least stands a chance to be the answer. I'm going to do about 2-3 more problems here. Let's go 3 over r plus 3 minus 2 over r minus 3, and that's going to be equal to negative 12 over r squared minus 9. Well, to find what I've got to divide to get my denominators out of here, I've got to take this as r plus 3 and r minus 3. So I have to factor that denominator there, which means now when I do the left side, I do the right side, and here I have an r plus 3, r minus 3. I have an r plus 3, r minus 3 on this side, and that should eliminate my denominators. So when I do that, my r plus 3's leave. I get a 3 times that r minus 3, so 3r minus 9, minus, over here, my r minus 3's leave, so I have a negative 2 times this 3, or this is r plus 3, which is a negative 2r, and it would be minus 6, okay, because I have to distribute the negative 2 to the positive 3. We get negative 6 here, and that would equal, these two guys would eliminate those two guys, and you get negative 12. So combine like terms over here, and I get r minus 15 equals negative 12. Add 15 to both sides, and I get r equals 3. Now, here's the fun part, right? If I've done my math right and everything, r is 3. But it can't be 3, because if I plug it in here, this would be 6. Yeah, that's great. But this would be 0, which would make this guy undefined. So my answers, I could have, when I started out, I could have answered this as anything, okay, except for the fact it couldn't be negative 3 or positive 3. Well, I've done my work. Everything turned out right. This doesn't have an answer, or that answer is not right. So I have no solution. So I must check at least my denominators to figure this guy out. Now the next part of this section is a little bit unique because we throw out the numbers and see if you actually know what the heck's going on. Over r plus r, and they're going to say for capital R. So I want, not right now, to solve for I want to solve for r. Well, this is really just a fraction set equal to a fraction, right? Because that's over 1. So I can go ahead, cross products that, and I get I times r plus r equals e. So now my r is at least on this side. Divide both sides by I, and I get r plus lowercase r equals e over I. And now I'm going to subtract the lowercase r off. So I get r equals e over I, and that's minus r because r will not combine with that term. And so that's my answer. Now you could get different looks for the same answer here depending on, well, maybe I distributed that guy. If I do, there's going to be an issue, okay, and it's going to look a little different, especially when I come down to here. Okay, so be smart enough to be able to manipulate your answer with somebody else's answer and make sure that they are still the same guy. And lastly, but not least, I'm going to try a 5 over p plus 2 over q plus 3 over r equals 1, and they're solving for r. Now r is in the denominator. I don't like r in the denominator. I'm going to get the denominators gone. So what I do to the left side, I do the right side and the left side, I'm going to get them all gone. So I'm going to take it times p, q, and r. P, q, and r to this side. So when I do, I distribute. My p's reduce. I get 5qr. When I distribute here, my q's fall apart. I get plus 2pr. When I distribute this guy over here, my r's fall apart, and I get plus 3 pq. And 1 times anything is that thing, so pqr. Now, here's the fun part, right? I got to solve it for r, which means I need r's all on one side so I can factor those guys out. So it doesn't really matter which way they go, doesn't look like. So I'm going to subtract this guy, put it over here. So I'm going to get, I have a PQR. I'm going to minus the 5QR here. I'm going to minus this 2PR from this side to put it over here, 2PR. And now I've got that 3PQ over here. So now I'm going to take this R and factor it out, which leaves me a PQ minus 5Q minus 2P. And none of these guys combine, which is fine. 3PQ over on this side. I'm going to go down, give me just a little bit more room here, because if I can hit the arrow down, I've got to divide this quantity off to leave me with R. When I divide the quantity off, I divide it by the other side as well. And I get PQ minus 5Q minus 2P. And when I do that, guy, there is my answer. Could there be a simpler form or a different form than that? Absolutely. But at this point in time, all I need to do is get R by itself, everything else away. So there is my answer. Here again, we're just making sure that the math works and that you understand the rules. Okay, if you have any problems, go ahead and give me a call.